Imagine you are 30,000 feet in the air. Put your phone in airplane mode right now. No Wi-Fi, no data, no signal. You can still ask your phone to summarize a dense document or draft a complex email and get a real answer in seconds. That is not a hypothetical. In 2026, you can run a genuine large language model completely offline using only your phone's internal hardware. Because it requires zero internet, it guarantees absolute data privacy. There is no server transmission. You don't need an account. You never pay a subscription. Every word stays on the device. The tech giants know this is the next step. Apple and Google are already baking small on-device models silently into their operating systems to power background features. But relying on background OS features is different from choosing to install and own a local model yourself. Setting it up manually gives you total workflow sovereignty. You choose the AI, you control the data, and it works wherever you go. This matrix breaks down the exact architectural difference between how we normally use AI and how local AI operates. It's a choice of where the heavy lifting happens. Under the cloud AI model, your phone is just a window. You type a prompt, it travels to a massive data center, runs against hundreds of billions of parameters on heavy-duty GPUs, and the server shoots the answer back to your screen. Local AI forces your mobile processor to do all the thinking. You download the entire model directly to your phone's physical storage, completely severing the tie to the server. The complexity of that download is measured in parameters. Think of parameters as the measurable brain power of the model you choose. The higher the parameter count, the smarter the AI, and the harder your phone has to work to run it. Which introduces a very real dilemma. You get absolute offline access and total data privacy, but you pay for it directly with your device's speed, battery life, and high-end reasoning skills. Local AI is not a direct replacement for apps like ChatGPT. It is a highly specialized tool. Deciding to use it requires you to carefully look at your environment and make a very deliberate trade-off. If you read up on mobile AI, you'll see a lot of hype about neural processing units, or NPUs. Let's clear that up. Your phone's NPU does not dictate whether you can run custom local AI. The absolute physical gatekeeper is your RAM. To function at all, an AI model has to load entirely into your device's active memory. This bar chart shows the hidden math of mobile memory. Your RAM is shared. Before you even open an AI app, your operating system instantly blocks out 2 to 4 gigabytes just to keep your phone running. So if your phone has under 8 gigabytes of total RAM, running local AI is highly impractical. You simply don't have enough overhead. The app will constantly crash or fail to load entirely. But if you step into the flagship tier, carrying 8 to 12 gigabytes of RAM, you cross the threshold. Now you have the clearance to comfortably load and run larger 3 to 4 billion parameter models. In 2026, the specific models that hit this sweet spot are Gemma 3, Llama 3.2, and Qwen 3. Those are the engines that actually work on modern phone hardware. Simply put, your physical memory dictates your ceiling for privacy. If you want absolute data sovereignty, you have to pay the hardware tax. Assuming you have the RAM, you need a gateway application to actually run the model. We're going to focus on free apps because they are where you should start. This split screen shows why PocketPal AI is the primary recommendation for both iPhone and Android. On the left, you get an interface designed for normal human beings. On the right, you get total freedom to download and swap between a massive grid of open-source models. If you are an Android user looking for an officially supported alternative, Google AI Edge Gallery is an incredibly polished option. However, it requires a strict trade-off. You get excellent zero configuration stability, but you are entirely locked in to Google's proprietary Gemma models. You cannot swap in a Llama or Qwen model if you want to experiment. You might also encounter paid one-time purchase apps like Private LLM. While they are great for desktop computers or high-end tablets, don't buy them for your smartphone. Your phone's physical hardware caps your processing power, regardless of how much you pay for the app. Your choice of app comes down to a single decision. Do you want total open-source flexibility over the brain you run, or are you willing to accept an optimized, closed ecosystem? We need to set realistic expectations about what happens when you press send. A 7 billion parameter local model is working with a tiny fraction of the brain power of a cloud model running hundreds of billions of parameters. complex reasoning will fall short. This line graph maps your generation speed, measured in tokens per second. Notice that as you ask your phone to run larger, smarter models on the bottom axis, your generation speed plummets. Practically speaking, that latency means real-time voice conversations are entirely off the table. The delay makes it feel like you're talking over a laggy satellite call. This quadrant chart maps out the steepest penalty of all: extreme battery degradation. Running continuous inference is exhausting for a mobile chip. A 3 billion parameter model sits in the top right, granting maximum privacy, but draining up to 50% of your battery in 90 minutes. You can mitigate this slightly, engaging power-saving modes within the apps, and forcefully closing your background apps to free up shared RAM will relieve some of that strain. And remember the one hard rule: you need a high-speed Wi-Fi connection exactly once to download the multi-gigabyte file. Do not try to download a model on a cellular network while waiting at your departure gate. Securing your data privacy requires physical energy. Local AI isn't an always-on feature. It is a tactical tool you deploy intentionally when the situation demands it. This flowchart maps your AI constraints. If you expect instant generation and battery efficiency, stick to cloud apps. But if you work in dead zones, handle sensitive client data, or want to avoid monthly fees, deploying a local model entirely justifies the hardware penalty. Accurately identifying your environment is the only way to know if moving AI to your pocket is a massive upgrade or a frustrating downgrade. So here is your mandatory execution checklist. Verify you have at least 8 gigabytes of RAM. Pick a parameter size your hardware can actually handle, and download the model over a strong Wi-Fi connection. Keep your expectations grounded. The digital companion you're building is going to be slower and simpler than the cloud apps you are used to, but you own it. And when you lose your signal or when the network fails, you're the one who still has a functioning intelligence tool right there in your hand.